Hi everyone, it's been a while but I'm back with a brand new video. For those who are new to my channel, my name is Olakunle and today we'll be building a fully automated DevOps pipeline from scratch. We'll write a simple Python web app and set it to deploy to Kubernetes on Minikube with every GitHub update. Using Terraform, GitHub Actions, Helm and argocd, we'll weave together key DevOps practices in a real-world setup that leverages DevOps principles. Sounds amazing, right? Yeah, I'm excited for this one as well. I've received so many requests on this topic, so I thought it's only right I deliver. By the way guys, I'm building a global DevOps community called CloudPros. We've hosted some amazing webinars, tackled exciting projects together, and we constantly help each other grow. If you're passionate about DevOps or just starting out, join us today to stay connected with all of our initiatives. I look forward to welcoming you to CloudPros. And without further delay, let's get into today's topic. To start, we need a Kubernetes environment to deploy our Python app, and Minikube will be perfect for this since it allows us to run Kubernetes locally. We can start Minikube directly with a command, but we're taking a more professional approach by using infrastructure as code with Terraform. Now, interestingly, Minikube does not have an official Terraform provider, but shout out to people like Scott the programmer who has created one that lets us manage Minikube as a Terraform resource. This approach makes it easier to document and reuse our infrastructure code, and we'll be tracking all files and configs created in this video via version control. So I've created a GitHub repo for this purpose. So let's head over to our IDE or code editor, and in my case, I'll be using Visual Studio. So first, we'll create a directory specifically for our Terraform configuration. This will keep our setup organized, and inside this directory, we'll create 3 files: main.tf, backend.tf, and variables.tf. These files will contain our main configuration, our backend storage, and any input variables respectively. So start by running mkdir terraform configs. So we're creating a folder called terraform configs. Then let's change directory to this folder. It says cd terraform configs. So we're in the folder now, and let's create our 3 files. So we can do that by typing touch main.tf, backend.tf, and variables.tf. Let's create an extra one, provider. So provider.tf, and we'll talk about this at some point. So provider.tf. Cool. So with our directory structure ready, we can move into the main configuration file, main.tf. This is where we'll set up our Minikube provider and cluster resource. By the way, a provider is like a bridge that allows Terraform to control specific services, and in our case, Minikube. Since we're using Scott the programmer's Minikube provider, we have to specify the Kubernetes source and version within our Terraform configuration. So in main.tf, let's define our provider. So we'll start for provider configs. We'll start by writing Terraform, open the curly braces, and then required providers, and then we have Minikube equals curly braces, and then we define the source, which is Scott the programmer Minikube, and then the version equals 0.42. So let's put this in curly braces. By the way, most providers in the Terraform registry provide this configuration, so it's very handy and you can fetch it from the registry. Let me show you how. So you could just do Terraform registry. You can search for that, like a Google search, go into the registry and just search for Minikube. So you can see Scott the programmer's provider, and then to use the provider, you can see exactly what we just typed. So let's go back to VS Code. And now that we have this set up, our required providers, let's specify the Minikube provider as well. So provider Minikube, and then let's open the curly braces. So let's enter the Kubernetes version. So Kubernetes version, and let's use version 1.3.0, so 1.30. Okay, so now that we have our provider in place, next we'll define a Minikube cluster resource using the Docker driver. So basically, this will set up our Minikube cluster in Docker containers, which is highly efficient for local development. So let's create a Minikube cluster resource by typing resource. The resource is a Minikube cluster. We need to give it an identity. So let's do Minikube Docker. Right, so next we have to open our curly braces. Next, let's define the driver as Docker. The Docker. So here, driver equals Docker configures Minikube to use Docker as its driver, which is lightweight and fast for local setups. So next, cluster name, and let's name it complete DevOps projects. So as you could tell, cluster name gives our cluster a name which is useful for identifying it if we're managing multiple clusters. So next, let's define add-ons. So add-ons equals, let's do default storage class and storage provisioner. So show it now. And basically, this enables Minikube add-ons with default storage class and storage provisioner, providing storage support to our cluster. Now that we have our Minikube provider and cluster resource defined, let's configure Terraform's Kubernetes provider. This will let Terraform interact directly with our Kubernetes cluster once it's up and running. So let's head over to our provider.tf file. In this file, we would add the Kubernetes provider configuration. And this configuration will pull connection details directly from the Minikube cluster resource, allowing Terraform to manage Kubernetes resources within Minikube. So let's enter provider, and the name of the provider, like I said, is Kubernetes. So Kubernetes. And then let's open the curly braces. Hosts equals Minikube cluster dot Minikube Docker dot hosts. And basically what we've just done is specify the Minikube cluster's API endpoint so Terraform knows where to connect. The Kubernetes provider also requires certificates to ensure secure, authenticated access to the Minikube cluster. So let's define them. So client certificates equals Minikube cluster dot Minikube Docker, very similar to the first, dot client underscore certificates. Then the client key equals, same thing with the top, Minikube cluster dot Minikube Docker. So let me just copy this. This is exactly the same thing. Sorry, I stayed on the same line. So yep, and then this should be client key, and then the last will be the cluster CA certs. So that's the cluster certificate authority cert. So let's just copy this again and reuse. We'll come and see, and then paste this here, and then the cluster CA certificates. Cool. So with our providers configured, we're ready to initialize and apply the Terraform configuration to start Minikube. Initializing will download required providers, and applying will start Minikube in Docker. But before we do that, Terraform needs a way to store information about the resources it manages, and it does this using a state file. In production environments, we'll typically store this file in a remote backend, like S3 or Azure Blob Storage. But for the purpose of our video, a local backend should be good. So let's configure the backend in backend.tf. So let's head over to backend.tf, and here we'll start by writing Terraform, and then backend, as we just said, local. So local, and then we have this, and then the path where we want the state file to be stored. So equals, let's do a terraform.tf state. Using a local backend is perfect for development environments as it keeps everything on our local machine. And if we decide to move this to a cloud environment in the future, we can easily change this backend configuration. Now that we've configured Minikube, our providers, and backend, let's get our Kubernetes cluster up and running. So first, we'll initialize Terraform to set up the working directory, and then we'll apply the Terraform configuration, which will set up Minikube. So open your terminal and type Terraform init. That did not seem to do anything, so I think that's because my files were not saved. So I've saved them now, and let's run Terraform init again. Okay, looks better. Oh, we have an error, so could not retrieve the list of, okay, so 0.42.0. So let me confirm from here. Oh, it's 0.4.2. That's why sometimes it's good to, copy and paste. Yeah, so it should be 0.4.2. So let me save that and rerun Terraform init. All right, that looks much better now. So we have a Terraform log file, and then let's run a Terraform plan, which should give us insights into what Terraform would create. Okay, so we can see it's planning to add one resource, and that should be our Minikube cluster resource. So let's run a Terraform, apply, and it will ask us for a confirmation. Yep, so do you want to perform these actions? Yes. So after applying, Terraform will provision Minikube, and we can verify that it's running, by listing the Kubernetes nodes. So it seems like we have another error, no major.minor.patch elements found. This seems like a version issue. So let's see. Scott the programmer, we set that. Oh yeah, so this should be v1.30.0. So let's save that and rerun our Terraform init. Terraform plan again. And let's run Terraform, apply yet again. Yes. So now Minikube cluster is creating. And like I said, we can confirm that it's created once the process is done. So the Terraform, CLI would let us know when, the cluster is done creating. So let's give it a bit of time. We have another error. Wow, interesting. Okay, so it says it can't connect to the Docker daemon. Okay, that's straightforward. I just need to start up Docker, and we should be fine. This is exactly what happens in the real life, So yeah, Docker should be starting up. Let's see. Yep, so Docker is running. So let's minimize this and run our Terraform plan again. So Terraform plan. And let's Terraform apply. Yes. While that's in progress, let's create a git ignore file. So .git ignore, which is where we specify, files that we do not want to commit to GitHub. So it could contain like, secrets or, just data that we don't want to, store in version control, but we don't mind having them, locally, or we want to have them locally. So first is our Terraform folder. So that's .terraform directory. So let's do a wildcard.tf state, and let's do a wildcard.tf state again, but this time also a wildcard afterwards in case it has a suffix. So nice, we can see that our cluster was created successfully. So let's do a quick check with kubectl to make sure that everything is set up correctly. To confirm that Minikube started correctly, we'll run kubectl get nodes. So let's enter kubectl get nodes. And as you can see, this command lists all nodes in our Minikube cluster. Great stuff. Seeing the node in the output means Minikube is up and running. And with our local Kubernetes environment set, it's time to move on to building our Python application. So now let's create a simple Python application that prints the current time. We'll containerize this application with Docker to make it ready for deployment in Kubernetes. So let's start by creating the Python code in a file named app.py. In this file, we'll write a small script that uses Flask to create a web server, which returns the current time each time you access it. So now let's create a new file called app.py. So here we start by writing from Flask. As I mentioned, we'll be using Flask, import Flask. And because our script will be printing the current time, we need to import time as well. So let's define app equals Flask, and then open brackets, name, yep. And let's set up our routes. So at app.route base path, so this, and then let's define our get current time function. So this is the main function in our script. So let's do that, and let's set current time equals time dot string format time, and then let's open this. Let's open our quotes, annotate the year. So this is the format, we want our time to come in, and then we do month, then the day, space, and let's do the same thing for hour, and the same thing for minutes, the same for seconds, right? And then let's enter the time.local. So no, that should be in small or lowercase. So time.local time method. So next thing we want to do is to return, so f the current time. So this will be our output that we'll see when we access our application as soon as it's up and running. And they should have current time, and that should be good. So let's also define the if name equals main. And basically what this does is it allows a file to run only when executed as a script. And then the next thing we do is app.run, So we have to specify the hosts. So in the host here, 0.0. And then let's specify the port for our app to run on. So port equals, let's say 8080. Cool. So just to recap, this code sets up a Flask server and listens on 0.0.0.0 on port 8080. Every time you access the root endpoint, which is the / you can see on line 6, it fetches and displays the current timestamp. Remember, the goal is to deploy this application to Kubernetes via a fully automated process. So let's address containerizing this application. And to do this, we need a Dockerfile. And the Dockerfile will define the instructions for building our container image. And if you want to learn more about Docker, check out my Docker playlist via the link displayed on your screen. So let's create a file named Dockerfile and walk through the configuration. Dockerfile starts with the from command, which initializes a new build stage and sets the base image for subsequent instructions. So let's create Dockerfile. So let's do cd touch Dockerfile. So that creates the Dockerfile. So let's enter from Python 3.9 slim. Here we're using a lightweight Python 3.9 base image to keep the build efficient. So next, let's set our working directory. So work, so this should be here, work dir, it should be r, /app. Next, we need to transfer our application file into the container, and we do so by using the copy command. So that is copy app.py into the working directory. We then install Flask with run pip install Flask. And next, let's expose port 8080 using expose 8080. And finally, to ensure our application runs when the container starts, we use cmd. That's command. So cmd, let's do this, Python, and then our app.py, so app.py. So let's save that. Let me save everything I've done so far, autosave, cool. With our Dockerfile ready, the next step is to automate building and pushing this Docker image to a Docker registry, and in this case, DockerHub. To automate our Docker build and push process, we'll use GitHub Actions, which offers a great way to handle CI/CD workflows directly within GitHub. Also, we'll set it up in stages and not all at once to keep things manageable and understandable, starting with building and pushing the Docker image. So first, we'll create a directory called .github/workflows within our project root. This is where all GitHub Actions workflows live. And inside this directory, we'll add a ci.yaml file, which will define the steps for our workflow. So let's head over to our terminal and do a cd ... and then let's do mkdir-p.github/workflows. So now you can see we have the directory created and a subdirectory which is workflows created as well. So let's do a touch, and we can just basically copy this and /ci.yaml. So we can see now that our ci.yaml file has been created. In ci.yaml, we'll start by defining when this workflow should run. We'll configure it to trigger and pushes to the main branch, as this is often the branch we want to deploy to production or staging. Well, Git branching strategies is a whole topic entirely, but we'll not be getting into that in this video. So let's configure the file. So we'll start by entering this in the YAML file, then the name of our pipeline, let's call it complete DevOps project pipeline. Cool. So let's do this on push branches, and this should be main. Again, this configuration means that whenever we push changes to the main branch, GitHub Actions will trigger this workflow, automating our CI process. Next, we'll define a job within this workflow to build and push our Docker image to DockerHub. So let's name this job build and push, build and push. So let's set it to run on an Ubuntu server, which is very stable for CI/CD pipelines. So runs on, let's do Ubuntu latest. Then we'll add each of the steps needed for this job under steps, starting with checking out the repository code. So let's enter steps here. And the very first step in most CI/CD workflows is to check out the repository code. For this, we'll use an official GitHub provided actions called Actions Checkout. This action downloads the latest version of our code base to the runner, making sure our CI pipeline has the most up-to-date files. So do that by entering the name, which is, let's set it to checkout code, and we need to define the actions. So it uses actions checkout, and let's use version 2. Next, we'll set a short version of the git commit hash, or SHA, however you might want to call it. This will be used as a unique tag for our Docker images to ensure that each build is traceable to the exact commit it came from. So let's enter the second step. So let's give it a name, and we can name it set short SHA, and then let's enter run to define our custom command. So run, and let's do that on a different line. So we do this echo short SHA, and let's go SHA equals, just enter this echo GitHub SHA, and then cut -c 1 to 7, and so let's close brackets and close the quotes. There shouldn't be a quote here, so let's take it out, and then let's do this GitHub env. So basically, this command extracts the first 7 characters of the GitHub hash or GitHub SHA, which represents the commit hash, and assigns it to short underscore SHA within the GitHub environment. Using GitHub underscore env ensures that short underscore SHA is available across subsequent steps in the workflow. Make sense? All right, cool. Now that we have our code checked out and have set our short commit SHA as a variable, we can build the Docker image. So let's define a step to build our Docker image. So another step, name, and let's name it build Docker image. And then let's run our command to build the image, just as we did for the one above. So next line, we'll enter docker build, and then -t to tag the image, the DevOps dude / let's name it complete DevOps project. And then let's do this to, and then let's enter m.short_sha and a full stop. This command tells Docker to build the image using the Dockerfile in the current directory and tags it with the GitHub sha for unique versioning. For our pipeline to push the image to DockerHub, we need to log in first. We'll securely use GitHub secrets for our DockerHub username and token to avoid exposing sensitive information. And to set these up, navigate to your GitHub repository settings. So I come to my GitHub repo, which is here, head over to settings, and then you should see secrets and variables. Click on actions. And as you can see, I already set up my, DockerHub token and DockerHub username. I mean, you can easily find how to create a Docker token with just a Google search. So that's like pretty straightforward, right? So my username is just my DockerHub username. So let me go into DockerHub actually, DockerHub, and then let me log in. So sign in. Yep, so I'm signed in, and this is my Docker username, my DockerHub username, right? So let's head back to our terminal. So now that we have our Docker secrets set in GitHub, let's define a step to log into DockerHub. So as usual, the name of the step, it should be in lowercase, name. So log in to DockerHub. And then as usual, let's enter run to define, the command that will actually log into DockerHub. So let's do echo. So echo, let's open quotes, $, let's open the curly braces, and let's enter our secrets DockerHub token. So I'll explain exactly what we're doing. So, but let's go on for now. So let's do the Docker login. Sorry, this should be in lowercase. I always forget to switch back. I don't know if it's just me. Most likely not. So Docker login, the username, and then let's do like something very similar to what we just did. So $, again. Yep. And let's do secrets DockerHub username. And once that's done, let's do password stdin, so standard input. This command reads the DockerHub token from our GitHub secrets, then pipes it directly into the Docker login command, providing secure authentication without hard-coding credentials. Once logged in, we can push our Docker image to DockerHub. This step ensures that our image is available online for our Kubernetes cluster to pull and deploy. So let's create another step to push our Docker image to DockerHub. So name again, as usual, push to DockerHub. And again, as you can guess, run. So pipe again, and then let's enter the command docker push, and the same tag that we have here is exactly what we need. So we can just copy this, this one, Oh, I just realized it's a DevOps due. Yeah, maybe the DevOps due. Anyway, let's copy that and enter that here. So Docker push the DevOps dude, complete DevOps project, and the version, right, which is the commit SHA. Cool. So just to recap, we're pushing the image with the tag we set during the build step. After the Docker push completes, the image should be accessible on DockerHub under our username. So under my username, the DevOps dude. So now let's test this pipeline by committing and pushing our current code to GitHub. So let's make sure everything is saved, autosave, and let's do a git add all our files. And of course, it would, ignore the files that we asked it to ignore. That's why you can see them grayed out. So .terraform and terraform state and, things with a terraform state suffix and prefix, right? So git add. So let's do a git commit and the commit message. Let's say we are live. So let's do that. So now we've staged our files to be, pushed. They're ready to go. So our remote, repository on GitHub. So now let's do a git push origin main. Okay, cool. Now that we've successfully pushed our code to the remote repository, we can head over to the GitHub Actions tab in our GitHub repo to watch the workflow run in real time. Once it completes, we'll check DockerHub to confirm our image was pushed successfully. So let's head over to the GitHub Actions tab and see how our pipeline is doing. So there seems to be an error. We're live. Let's check on the error. So it's in the build Docker image step. Says invalid tag, invalid reference format. Okay, cool. Let's check that step to see. So it's Docker build -t. Yes, this looks good. Okay. So the next thing I'll think about is, let's see if it was able to pick this up. So let me go back there. Seems not to have picked up that tag. So I think the problem might be with the, commit SHA. So let's see what's going on with that one. So it's here. Let's trace it back to this place. Short SHA echo. Oh, this should be GitHub, not GitHub. So let me save that and push again. So let's do a git add, and this is the file that we're adding. So copy the path and git commit. Let's say fixing typo, and then let's do a git push origin main once again. And yeah, let's check the actions tab now to see if that sorts out the issue. So it's on the build and push. Yep, cool. Yep, seems to be good now. All right, so we just give it some time. Shouldn't take so much time. The login was successfully, seems it's pushed successfully, and yeah, that fixed our pipeline. All green. I love to see green. Now let's go to DockerHub, refresh, and see if we have that. Awesome. So now we have our complete DevOps project image successfully pushed to DockerHub. Now that our Docker image build and push process is automated, we're ready to set up Helm to manage our Kubernetes deployments. Helm is essentially a package manager for Kubernetes, which simplifies deploying and managing configurations across clusters. So let's create a Helm chart for our Python application. In our project directory, we'll use the Helm create command to generate a Helm chart template. This chart will include all necessary configurations such as Kubernetes deployments and services that we can customize for our application. So let's go ahead to the terminal and get that done. So Helm create, and let's name our Helm chart complete DevOps project time printer. Cool, so that should create our Helm chart template. And as you can see, a new directory and subdirectories have been added to our project. Now let's go through each file we need to configure. Inside the Helm chart root directory, we'd find a values.yaml file. This file is central to Helm's flexibility and allows us to define reusable settings such as image information and Kubernetes service types. So let's open the values.yaml file and configure it based on our specific application and Docker image. So I always like to clear this out completely. I mean, it's really whatever works for you, but for me, I like to clear out, especially for like small projects. So let's start filling it up. The things we need the image. So that's our Docker image. And we need to enter repo Z3. For repo Z3, it's the DevOps. So it's the DevOps dude. It's already filling it out. So that's cool. So the DevOps dude. And then the repo Z3 name, that's the Docker repo name, complete DevOps project. Cool. The next thing we want to enter is a tag. We can enter latest for now, but we'll still come back to the tag because there's a reason why we were using the commit sharp, and we'll see that as we progress. So, no, sorry. So, not Ubuntu latest. So the next thing we want to enter is a pull policy. So for our image, so pull policy in camel case, and if not it should be present. So here the repository and the image tag set the Docker image for our application pointing to DockerHub. We're also updating the image tag dynamically in our GitHub Actions pipeline as new versions are created. And for the image pull policy, it is a configuration setting that tells the Kubernetes kubelet when to direct the container runtime to pull an image from a registry. So next, let's configure our application's Kubernetes service as a cluster IP service, which exposes it internally within the cluster. So to do that, we enter service, and then the type, as I mentioned, cluster IP, and then the port, which is 8080 if you remember from our Python app. Also, in our values.yaml, we'll be disabling ingress, service account, and auto-scaling, as the purpose of this video is to use only the resources or features we require to display DevOps tools in action. And to do that, let's enter ingress. So ingress enabled set to false. The next was service account. The same thing for it, enabled. Sorry, one more space here. Yep. Enabled is also false, and the last one should be auto scaling. And let's do the same thing. Tab enabled set to false. Now our values.yaml file is in a good place for us to start. Now let's modify the deployment.yaml file under templates to use the values defined in our values.yaml file. This will make it easier to update configurations without modifying multiple files. So now let's head over to our deployment.yaml file to ensure that it looks good. So deployment, yep, the name. Let's just glance through it, especially the fields that we defined in our values.yaml file. So port, yep, values service.port. Let's confirm that, yep, service.port. Let's go back there and check for like the images as well. So container, yep, values, image repo, and then the tag, yep, that looks good. Or if these are not specified, like if the tag, is not specified, then it would default to like the chat application version, and that's okay. Then values, image pool policy, that looks good as well. What else do we have specified? Yeah, I think that's basically it. The rest are disabled, so that's fine. Cool. Now our Helm chart is ready to deploy our application. With our Helm chart now configured, the next step is to enhance our GitHub Actions workflow. We'll update our CI pipeline to modify the Helm chart's image tag after each build. This change ensures that our Kubernetes deployment uses the latest Docker image. And since we plan to implement GitOps, argocd will be monitoring our repository, auto-detecting the updates, and synchronizing the cluster. Let's go back to our ci.yaml workflow file and add a step to update the Helm chart's image tag in values.yaml. We'll use the Linux sed command to find the tagline in values.yaml and replace it with the GitHub char tag. This way, each time we build a new image, our Helm chart gets updated with the latest image version. So let's head over to our ci.yaml and define the step to update our Helm chart with the new image tag. So we come back here, and next thing we want to do is to add a new step. So let's name it update Helm chart. Chart with new image tag. And then, as usual, let's do our run pipe. So, like I mentioned, we'll be using the Linux sed command. So sed-i, let's open quotes. So S, the tag is what we're looking for, and then slash the tag, another colon, and then let's pass in the environment variable, which is the char. So environment dot short char, and then there should be another / here, and then now we need to define the path to our values.yaml file. So we can just copy the relative path and then enter that here. Cool. And then for the next step, let's do a git add, the same thing. So after git add, let's do git commit -m, and let's just say, updated image tag to environment dot short char. So m dot short char, and then we need to do a git push. As I mentioned, the sed command searches for the line where our image tag is defined and replaces it with a GitHub short commit hash. And our pipeline will also run git add and git commit, which stages and commits the updated values.yaml file respectively. And git push, as you already know, pushes the change back to GitHub, triggering argocd to synchronize the Kubernetes cluster with this new version. I know you probably can't wait for us to get to argocd already. Don't worry, we'll be getting there shortly. So with this new change to our ci.yaml, every time we push code, the workflow will not only build and push the image to DockerHub, but will also update the Helm chart with the new image tag. This setup keeps our CI/CD pipeline fully automated, ensuring Kubernetes always has the latest version of our app. But for this bit to work, there has to be a Git author that the pipeline will assume in order to write to the repo. We'll simply do so with the following. So let's define a step, and that step has to be before the step to update the image with the tag. So let's do name as usual. So name, and let's name it configure git author. So here let's also do a run pipe, and then the next line is the git config local user email, and let's enter hello at the DevOps.com. So now let's enter the Git username. So let's do git config local user dot name, and in quotes let's do the DevOps dude 01. Awesome. I hope this has been straightforward and helpful so far. So now let's set up argocd, which is central to our GitOps workflow. In a GitOps setup, all application configs and infrastructure definitions live in Git repositories, with tools such as argocd ensuring that our Kubernetes cluster always matches what is defined in Git. It does this by continuously monitoring our GitHub repositories for any updates. And when a change is detected in the Helm chart, argocd automatically synchronizes the Kubernetes cluster to match the desired state, creating a reliable and automated deployment pipeline. So let's head back to Terraform and get argocd deployed using Helm. So let's start by defining the Helm provider, and let's set this up in our provider.tf file. So let's close this for a second and head over to our Terraform config. So provider.tf. We already have the provider for Kubernetes, so let's add one for Helm. So provider and then Helm. Yep, this should be Helm, and let's open brackets, close. So let's enter Kubernetes and a config path. Let's just say config underscore path equals, the path to our kube config or our Kubernetes configuration, which has, details around Kubernetes clusters that we have stored on that particular machine. So in this case, this is the path to my kube config file. So it's .kube and /config. Next, let's write out the config to deploy an argocd Helm release. So for that, let's create a new file called argocd.tf. And in this file, let's define resource. And this is the Helm release. Let's name it argocd for simplicity. So argocd. And as usual, with all resources, you need to open the brackets and define a name for the resource. Let's name it Argo again. So argocd. Let's put that in quotes because it's a string. So next, let's enter chart equals argo-cd. And let's enter the repository where the argocd Helm chart is stored. And that is https argoproj, so argo project github.io/argo helm. Yep, it looks good. All right, so next thing, let's enter a namespace. So namespace equals argocd. And if the namespace doesn't exist, let's do create namespace equals true. Let's also add some values, default values. So values, this, enter EOF, server, service, type, cluster IP. That should be, yep, tab EOF. So basically, the Helm release, as we've defined here, installs the argocd Helm chart directly into our Minikube cluster in the argocd namespace. To apply this configuration and install argocd, we'll run the Terraform commands once again. And once that's completed, argocd will be deployed and running in our Minikube cluster. So let's head over to our terminal and do a cd back into the Terraform directory and make sure everything is saved. Yep, cool. So let's do a Terraform init. It's essential to do an init once a new provider, is added. So Terraform init. And as you can see, it installed HashiCorp Helm, plugin. So let's do a Terraform plan. And you can see it's trying to create a new resource. So you can see it's a Helm release argocd. So let's apply that. Terraform apply. Yes. So let's wait for it to, set up appropriately. By the way, we can even just check in our terminal to see what's going on. So if we do a kubectl, let's get nodes first. Yep. So let's do a kubectl get namespace. So we can see argocd namespace was created 29 seconds ago. Let's check all that is in there. So we can get all, that's all resources in the argocd namespace. So we can see the bulk of them are up and running. So this is completed. I believe our Helm chart should be, if not installed already fully, then almost, yeah. So our Terraform apply was successful. One resource has been added. And as you can see, argocd applications are all up and running and in a healthy state. With argocd deployed, we can now access its dashboard. The dashboard provides real-time visibility into all applications it manages, including their synchronization status and health checks. To access it locally, we'll use the kubectl port forward command. So we can do kubectl port, let me clear this, sorry, Control L. So we use the kubectl port forward and then the argocd service name. Let's see if we can get that from here. So service, yes, typically it's the Argo server that runs on port 443 and 80. So it's argocd server, and then the namespace, which is argocd. The port we want it to run locally, let's use 8081, and let's map that to 443. So let's run that. This command basically forwards traffic from your local machine to argocd server in the Minikube cluster. And you can access the dashboard by visiting, http localhost 8081, which is the port. So let's do that. So let's head over to the browser and do a localhost 8081. So it says not secure, which is okay, for the purpose of this video. So let's proceed. And we can see the argocd user interface is ready. So it says, let's get stuff deployed. It looks so excited. Anyway, how do we log in? argocd uses a default admin password stored in a Kubernetes secret. So we can retrieve it in order to log into the dashboard. And to do that, let's head back to our terminal. Let's open a new terminal. So let's do shell, new tab. Yep. And let's see if this session has all the states that we need. So let's just do a kubectl get namespaces. Cool. So the command to get the Argo initial secret is kubectl get secret argocd initial admin secret argocd, which is the namespace, and then we use the JSON path. So JSON path equals Let's open quotes and close the quotes. Open curly braces as well. So it's .data.password. And let's close the quotes and then base 64 decode. Basically, Kubernetes secrets are base 64 encoded, and that's why we have to decode it, right? So let's enter that. So this is the password. So let's grab that, and the username is admin, and let's enter the password, sign in. So now we're in, right? So this is what the argocd user interface looks like. We have no applications, we have no repos, nothing yet, right? Just the username and the password, and we're in. Personally, I love to use the CLI a lot, so I'll also log into argocd via the CLI. So basically, you do that by running argocd login, and then it's local host 8081, which is where argocd is like listening on, and then admin. So sorry, that should be username, which is admin, and then password, which we can just grab from here. Sorry, so password, and then we pass the insecure flag. So enter. So as it says, admin login logged in successfully. Awesome. Now, with all these being done, to enable argocd to monitor our GitHub repo, we need to define an Argo application resource. This configuration will tell argocd which repository to monitor, the path to our Helm chart, and the desired namespace in Kubernetes. So let's create our argocd application file. So let's head back to VS Code. Yep, and we can create this in the root of our repo. So new file, argocd, let's call it argocd-app.yaml. So let's start defining the argocd application config. So first is API version, and for API version, it's argocd.io/v1 alpha 1. The kind, so the kind is application, sorry, so application, and then let's define some metadata, should be in lowercase, metadata, and then let's give it a name. What should we call it? Let's call it what do we call it? Let's stick to complete DevOps project, and then project, and let's come back here and change this. So for namespace, let's keep it consistent and keep it in argocd namespace. So next thing we want to do is enter spec, so that's the specification, project, let's put it in the default project. This is basically just an argocd project. So source, and under source we should have the repo URL, and for this let's grab our repo URL. So here we come here, this, let's grab this URL, come back here and put it in quotes. Yep, so yeah, repo URL. So yeah, complete DevOps project, that looks good. Then we need to set the target revision. So sorry, there should be in common case as well. So target revision, and we set this to head so the argocd can track the latest commits in the main branch. So next thing, a path, and in this case our path will be the path to our Helm chart, which is this, right? So if we do copy relative path and stick that into this place, yep, that looks good. So yeah, we've defined the source, and next thing we need to define the destination. So details around a Kubernetes cluster, right? So server, and for the server, we could just use the default, address. So that would be HTTPS. So this is basically just the Kubernetes in cluster, default address. So default the SVC. Yeah, cool. And next thing, namespace, we can have this in default. And then lastly, let's define our sync policy, which enables automatic synchronization and self-healing, ensuring Kubernetes always matches the Git defined state. So to do that, let's enter sync policy. And then here we have automated, because we want it automated, and then prune true, and then self-heal as well should be true. So let's save that. Awesome. To allow argocd to connect and securely monitor our GitHub repository, we need to set up a personal access token in GitHub and then add it to argocd as a repository credential. The personal access token allows argocd to authenticate and access the repository for read-only purposes, monitoring for any updates to our Helm chart. So head over to GitHub, and what you want to do is go to your user profile, go to settings. Under settings, you should see developer settings, and there you can create a personal access token. So create, and then for the name, let's name it complete DevOps project. 30 days, let's do 7, and basically let's give it repo, so full control of private repos. I don't think it should need more than that, because that should cover the read permissions that it actually needs, right? So let's keep it with that. Generate token. Usually the token comes up, just once, so you have to save it in a secure place, because you won't be able to retrieve this again once you refresh the page or something. So I'll copy this. It's very temporary for me. Probably going to delete it immediately after the video. So yep, I'll save it here. So with the personal access token ready, we'll configure argocd to use it for secure access to our GitHub repository. We can achieve this either via the argocd user interface or the CLI, specifying the server address to ensure proper connection. So to do so, I would do it in the CLI, so you can run the following commands in your terminal. So let's head back to the terminal and run argocd repo, and then, it should be add, and then we get our repo. So let's go back here, let's go to this, and let's get the link to our repo. Back to the terminal, let's enter that. And next thing, we need to enter the user name, so that's the GitHub username, and mine is the DevOps dude 01. Let me just confirm. Yep, the DevOps dude 01. Cool. Next thing we want to enter is the personal access token that we just created. So password, and then let me grab that from where I saved it. So this, put in quotes. So that's the personal access token. Then the next is the server, which just like we did above, we can just grab that here, enter, and in secure. The insecure flag tells argocd CLI to skip TLS verification for the server connection, which is necessary when working with self-signed certificates in development environments. But note that while insecure is convenient for local testing, it is not recommended for production environments. For production, it's best to use a trusted certificate signed by a recognized certificate authority. That being said, let's complete the process of adding our repository to Argo. So I'll just enter, and then it says repository. This added, so that was successful, because if it wasn't, we'll most likely have gotten an error. But we can confirm from the argocd UI. So let's go here, let's go to settings and check on repositories, and as you can see, it was added and is connected successfully. And just to recap, the command we just ran securely stores the personal access token within argocd, allowing it to authenticate with GitHub and continuously monitor the repository for updates to the Helm charts. So the next thing we should do right now is commit all of our code changes to GitHub. I just remembered we've not done that. So let's go back to VS Code and let's add all of this to GitHub. So let's auto save. Let's make sure everything is saved. Let's go back to the root of the repo. Let's do a git add. Let's add all of it. Let's do a git commit and then a commit message. Let's say adding more configs. Right? Cool. So let's do a git push origin main. Awesome. So let's quickly check on the Actions tab in GitHub to be sure that, everything looks good. So there's an error. It says fatal, permission to the repo denied to GitHub Actions. Okay, usually this should be fixed if we come to here. So settings, actions, general. Let's see, workflow permissions. Let's give it a read and write. Permissions, and let's save. So now that we've done that, let's come back here and let's retry. Let's rerun all jobs, right? So rerun jobs, and let's just make sure that, the pipeline runs successfully. So as you can see, that fixed the issue and our pipeline ran successfully. So if we check, we'll see that there was a new commit to update the image tag in this file. And if we check the file, so that's in Terraform configs. No, sorry, that should be in here, and then values.yaml. We can see that the commit was also successful. Now let's deploy the argocd application so argocd can begin monitoring our GitHub repository and automatically sync any changes. So to do that, we'll run kubectl. So let's head back to VS Code or the terminal. So anyone, we can do it from here, kubectl apply -f and then the argocd-app. So there's an error. It says resource mapping not found for this name. No matches for application in version argo proj. This is alpha. Okay, should be alpha. So let's change that real quick. So it should be alpha. Let's save that and run the kubectl command yet again. And yep, it was successfully created. Awesome. Let's push this real quick up to the GitHub repo as well. So let's do git add this, git commit, and let's say fixing typo. So we have to do a git pull first because there was an update, after I pushed, which was the automated, commit to update the image tag. So you need to pull the changes first. If not, I'll get an error. So, all right, let me just do this for it to merge the changes back into the main. So let's do it again, git pull. All right, so let's merge that in, and then I can git push. All right, awesome. And now that we've created our argocd application successfully, argocd will detect this application and begin monitoring the GitHub repository for changes to the Helm chart. This setup allows for seamless deployment, ensuring any changes in Git are automatically reflected in Kubernetes. So let's take a brief look at argocd dashboard. So let's go back and see what's going on in that world. So if we come to applications, amazing. We can see LT synced, synced okay, and it created a pod 3 minutes ago. argocd dashboard gives us a complete overview of our application synchronization state. If everything is configured correctly, you can see our application, the complete DevOps project, is up and running. And if any issues arise, like a failed deployment or a configuration drift, argocd will display warnings. Always, it does that, making it easy to identify and resolve issues. Self-healing is one of argocd's powerful features. For example, if someone manually changes a resource in Kubernetes, argocd will automatically detect the difference and restore the correct state as defined in the Git repo. This ensures our production environments always match the desired configuration. With everything set up, it's now time to test our end-to-end pipeline. We'll make a small update to our Python application, commit and push it to GitHub, and then monitor how argocd synchronizes these changes, like it's doing right now as you can see, with our Minikube Kubernetes cluster. This test will confirm that our CI/CD and GitOps pipeline is fully operational, from code changes to automated deployments. So let's start by making a small change to our Python application in app.py. And to do that, let's head back to VS Code, app.py, and we can say the current time of the day, and that change is good enough. So let's save that and push that up to GitHub. So auto save. Let's get the path to this file. So copy relative path. So git add the file, git commit message, and let's say updating Python app, and let's do a git pull again, just like I explained before. We need to pull, and then let's do a git push yet again, and watch our pipeline do its thing. So let's head back to GitHub Actions and see that it all runs fine. So actions, we can see it running. Let's just monitor it, and as you can see, it ran successfully. So let's head back to argocd and see if it detected our change. So this is 4 minutes ago, so it's probably not. So one thing we can do is just click on the sync button. So let's do a replace. Yep, that should be fine. Synchronize. Yep, that should be fine. It should fetch all the latest code changes within our repo. And it's handy to do that, if we're not seeing our changes as quickly as we want to see them. So now you can see a new pod has been spun up a few seconds ago. From the argocd UI, you can also see like events on the pod. So 17 seconds ago, it successfully pulled the image, from my personal GitHub, repo. And then you can see logs on the application, right? So great stuff. So let's go back to argocd. Let's close this. And another way to confirm that, the latest changes have been made is to look at the, the commit, right? So as you can see, if we check our repo and check for the latest, commits. So if we come here, you can see it's 2AE722E. So you need to check the last sync and see that the commit message, is exactly the same thing with the comment. So we're definitely sure that the latest change from our GitHub repo has been synced by argocd to our cluster. As we can see that the pod, is also running appropriately. And if we inspect it properly, we should see the same tag. So as you can see, the 2AE tag is also here in the pod's manifests. Now let's access the application to verify the new version is running with the updated print statement. And to do so, we'll use port forwarding. So let's head back to our terminal and port forward our application so we can access it via our browser. So as we did earlier, if we do a kubectl, so let's first do a kubectl get pods or namespaces. So this is our pod running just fine. Just the same thing with every other application. Our cluster is super healthy. So let's do a kubectl port forward. By the way, you might be wondering that I did the port forward with a service before, but now I'm doing so with a pod. So you can actually port forward a pod or a Kubernetes service. Either of them, should be fine. So our application is running on port 8080, but then we need to open it up on a port locally as well. So let's do the same 8080, right? It doesn't hurt. So we need to also give the namespace for our service, which is default. It will equate to not giving it a namespace, but it doesn't hurt as well. So let's head over to our browser and see that we get the latest message which we just updated in our Python app. So local host 8080. And so there's an error. So let's change this to HTTP. Amazing. So the current time of the day, 2024/11/03, 11 p.m. Wow, it's exactly 11 p.m. That's amazing. So yeah, let's check this so we can see this is exactly what we wrote here. This is the update, the current time of the day, and that's exactly what we get here, the current time of the day. This result confirms that our GitOps pipeline from GitHub Actions to argocd and Kubernetes successfully deployed the new code. If you don't see the updates, then you can troubleshoot by reviewing the argocd dashboard for sync issues, the GitHub Actions logs for pipeline errors, or checking Kubernetes directly with kubectl commands in order to diagnose any deployment issues. If you have watched this video up to this point, congratulations! You've successfully built a fully automated CI/CD and GitOps pipeline from the ground up. Starting with provisioning Minikube using Terraform, we moved through containerizing our Python application, creating a flexible Helm chart, and setting up GitHub Actions to automate builds and pushes. Finally, we connected everything with argocd to monitor our repository and synchronize our Kubernetes cluster effortlessly. This setup demonstrates the power of combining CI/CD pipelines with GitOps principles to manage and deploy applications seamlessly on Kubernetes. Now, it's worth noting that while this setup showcases core concepts, real-world production environments often require additional considerations. In production, where applications are directly serving end users, there's a need for more thorough testing, including unit tests, integration tests, and end-to-end tests to ensure reliability. Security testing and vulnerability scanning also play a crucial role in production CI/CD pipelines to safeguard data and maintain compliance standards. Additionally, production pipelines often include steps for promotion from development to staging and then to production environments, introducing deployment gates and manual approvals to mitigate risk. This video is focused on sharing insights into integrating Terraform, Helm, GitHub Actions, and argocd to build an automated CI/CD pipeline. The principles shown here are foundational, but they can be adapted to meet the scaling, reliability, and security requirements of a full production environment. If you found this video helpful, please like, subscribe, and share for more content on DevOps, cloud computing, and automation best practices. Thank you all for watching, and I look forward to seeing you in the next video. Bye.